to IMS Academy. I welcome you all in this smart revision session of theory of machine. Right. So I hope already you have enjoyed our smart revision sessions for different subjects. Right. And we have completed about thermodynamics, industrial engineering, engineering mechanics. Last only have completed. This theory of machine I will be conducting the smart revision session in two parts. Half of the syllabus I will be completing today and half of the syllabus in the next session. So the purpose of this smart revision session is just to have a quick revision of all the concepts. Okay, in this last moment, all the formulas and the relations and the important concepts are what we need to remind. Again, we have to remember all those things. We have to again revise it multiple times. And please, everyone, I am suggesting everyone to give mock test as well. Okay, because from the mock test only you will able to understand where you are doing wrong. Okay, what are the mistakes you are doing. So you will understand those mistakes and then you will work on those mistakes. So in this particular smart revision sessions, I will be discussing the important concepts straightforward. And in this session, see, you have to take a copy and pen and just note it down all the important formulas and the important relations. And if any doubt if you are having, you can directly ask in the comment box itself. Chat box is there, directly put up your questions and I will love to answer all of your doubts. Okay, whatever the doubts you are having, I will reply in that. Right, okay. Now, before starting, some information I want to give you regarding the Telegram group. In this Telegram group, if you join, you will be getting all the latest updates of the job notifications. You will be getting quiz that will help you for your technical exam preparation. Apart from that, you will be getting the latest information about the webinars that we are going to conduct for you. Okay. Thank you, Pragya. Right, and some important sessions we are going to take in this Telegram group. So with this link, you can join this Telegram group. Now, second thing is about the IMS Academy online live program in which we are taking more than 800 hours of classes. Apart from that, you will be getting theory books, exercise books for your practice, okay, so that you don't need to depend on any other reference material. Apart from that, 12 mentorship sessions you will be getting in which you will have a direct connect with the faculty. Whatever doubt or challenge that you will be having in your preparation part, you can discuss with the faculty and all of the doubts will get resolved. Okay, you will get personal attention in this particular live online program. And most important thing is the online test series with the video solutions you will be getting. So if you are interested, you can book the free counseling sessions here. Okay, these are the numbers in which you can call and book your free counseling sessions and you will get more detail about the live programs when it is going to start. Okay, for every branches. Now I will start our theory of machine session here. Okay, so these are the syllabus that we have in our theory of machine. Mechanism we are having, then flywheel, gear train, balancing, governor, gyroscope, vibration and cam follower. So if I talk about the important topics, let's suppose in the last phase, if you ask, sir, what are the important topics that I need to study, okay, that must I need to complete. Okay, I should say these are the must topics that you should complete at least. So if I say first of all the simple mechanism, right, then you have this gear train and this vibration part. These are the three topics from which definitely sure shot you will be getting the questions. So you need to revise these topics at least multiple times. Okay, simple mechanism and vibration and this gear train. Every year if you see previous year, just a small analysis if you do for previous year questions, every year vibration questions you will find, every year gear train problem, every year simple mechanism problem. Okay, so in this session I will be completing this of the topics. Some of the topics I will complete today and second I will be completing in next session, remaining topics whatever left. Okay, so we'll start with simple mechanism, everyone. See, in simple mechanism, first topic that we have to discuss is the degree of freedom. Okay, some of the time they will be asking this question, calculate the degree of freedom, and I hope you remember the equation that we are going to use to calculate degree of freedom. The equation is Kutzbach equation. Okay, so the formula that we are having for degree of freedom is 3n minus 1 minus 2j minus h. Now here very important part, n is what number of links. Okay, j is our binary joint and h is number of higher pair. Now very important part here you need to understand, this degree of freedom belongs to a planar mechanism. This formula belongs to the planar mechanism, right? For planar mechanism. Now, very important point you need to understand, some of the time you will be having redundant link, you will be having redundant degree of freedom. So most of the time what happens, students are confused between redundant link and redundant degree of freedom. Now what is the basic difference? Can anyone tell me the difference between redundant link and redundant degree of freedom? Okay, anyone? Please tell me what is the difference between redundant link and redundant degree of freedom when you will call any member as a redundant link. Okay, I will give you example also here, but before that, if anyone knows, so please mention in the chat box here. Right, so okay, let me tell you what is redundant link. So let's suppose these are the 4 members. Okay, these are the 4 members, and let's suppose this is the fixed. Now one more member I have attached. Okay, one more member I have attached here. Okay, but this member has been placed. Okay, please understand very carefully. The member I have attached here parallel to both the members. So parallel to this one. This member is parallel to this one and as well as with this one. So all 3 are parallel to each other. Now in this mechanism, if you please try to observe here. Very good evening student. So the point you need to understand here is, if I remove this link also, there will not be any effect on the mechanism. There will not be any effect in the mechanism. Are you getting the point? If I remove this red link, there will not be any effect in the mechanism. It means this is acting as a redundant link. So whenever you will find any redundant link, you have to subtract that link, or basically you have to remove that link. Then you should calculate. Okay, then you should calculate the degree of freedom. 3 parallel but not. Obviously, see, understand. As all 3 are parallel, so if I remove this middle one, it is not going to affect the mechanism. But very important point. Same mechanism if I am taking, let's suppose, again I will draw, no issue. Again, same mechanism I am taking, right? But this time, member has been placed like this. Now, in this case, can you tell me this red one is a redundant link? Please tell me. Is this red member is behaving as a redundant link? Yes or no? Is it correct to say the red member here is a redundant link? Is it possible to say? No, not at all. See, orientation is different. Here it is placed in such a way that all 3 are parallel to each other. But if I place in this orientation, it will definitely affect the mechanism. Let's suppose if I am rotating this link, if I am giving the rotation to this link, definitely this link is going to oppose the motion of the link. So that's why in this case it is not redundant link. In this case it is redundant. So actually the formula that we have written here previously, this formula, right? It doesn't consider the orientation of the member. That is the disadvantage or limitation of degree of freedom formula. If someone asks what was the limitation of this formula, simply you should say, sir, the basic disadvantage or limitation is it doesn't consider the orientation of member, how it is placed. It simply counts number of links, number of binary joints and number of higher pair. No, basically no regards we have given to the orientation of member. Okay, so that's why this is very important. So the point we should remember here, degree of freedom, whenever we are calculating, we should remove redundant link and then we have to find degree of freedom. Then find degree of freedom after removing that link. Now this is with regards to redundant link. One more thing, okay, let me write it here, redundant link. Okay. Then one more thing is there, redundant degree of freedom. Now in redundant degree of freedom what happens? For example, one example I will give you. Right. Now this, look at this red member here. Okay, everyone, please carefully understand this red member. If I give some little force or if I apply small force to this red member, it will come out of the link. It will come out of the mechanism actually. Or better I can say, this red member can have a motion without affecting the other part of mechanism. One of the link is having a motion, but that motion is not affecting other parts. This red link can move without affecting the other part of mechanism. So basically this link is having one redundant degree of freedom. So please understand the difference between redundant link and redundant degree of freedom. Redundant link means any extra link which is not affecting mechanism. Here in this case, one link is having extra motion. There is one link which is having extra motion. That motion is not going to affect other part of the mechanism, right? In complex mechanism, how to identify? Simply you have to visualize the mechanism. See, only way to understand whether the link is redundant or not, or whether the link is having redundant degree of freedom or not, you have to visualize. Okay, because all of the mechanism that we are getting in this case is not complex, simple mechanism. See, the chapter name is simple mechanism, which means planar mechanism, and only 4 members will be given to you. Okay, obviously if a very complex mechanism is given, it is very difficult to identify. So that's why in our syllabus only planar mechanism, first of all links will be in a plane. Second, maximum 4 links they are going to give you. Okay, in that case we can easily identify. Now one more example I want to give you here. Let's suppose now this link has been placed like this. Now please tell me, in this case can I say this red link is having a redundant degree of freedom? Is it possible to say? In this link, can we say this is a redundant degree of freedom? In this case, we have clearly mentioned if I move this red link, other part of the mechanism is not going to get affected. But in this case, if I move, try to give the motion to the red link here, in this case, definitely other part is going to get affected. Other parts will definitely get affected. So that's why in this case, it is not having degree of freedom, redundant degree of freedom. In this case, it is having redundant degree of freedom. So what you will do? Whatever degree of freedom you have find out here, you have to subtract the number of redundant degree of freedom. Got the idea? So in this case, the link is not having redundant degree of freedom. In this case, it is having, okay, redundant degree of freedom. Okay, in this case, it is not having any redundant degree of freedom. It is fine, no issue. But here we are having a redundant degree of freedom. How many redundant degree of freedom? 1. So whatever formula you have applied, in that you have to subtract this redundant degree of freedom. So let's suppose how many links? 4 links. Okay, all are lower pair. You will get the degree of freedom 1 from the formula. Again, we have to subtract 1 degree of freedom because it is redundant, right? So resulting answer will be 0. Actual degree of freedom answer for this particular mechanism is 0. And for this one, from the formula you will get 0, but actually it is having 1. Because this redundant link I have to remove, then I have to calculate the degree of freedom. So what is the modified form of degree of freedom? Okay, if I have to write modified form of degree of freedom, I will write it like this: 3 into n minus nr minus 1 minus 2j minus h minus fr. So fr is the redundant degree of freedom, nr is the number of redundant link. Understand this point? nr is our redundant link and fr is what? Redundant degree of freedom. So this is the modified formula. Okay, but still if you have remembered this formula also, the basic one, you should understand if any redundant link you are finding out, remove it. Any redundant degree of freedom you are finding, so basically remove that also. Fr, no, how it will add? So if you are having redundant degree of freedom, you will be adding. How is it possible? Then you will say, okay, so degree of freedom for this one will be what? 2. No, redundant degree of freedom we have to subtract from the degree of freedom, that answer we are getting from the formula. Whatever answer you are getting of degree of freedom from the formula, you have to basically subtract that value from the redundant degree of freedom. Redundant degree of freedom here answer is 1. What is the extra motion we are having? How many extra motion? Only 1 extra motion we are having. So redundant degree of freedom value is 1. From the formula I have calculated, okay, from the formula whatever answer I have calculated, from that value I need to subtract fr value. This fr, I will call this one as fr. So I will subtract this value. So that's what I've written. I hope it is clear. Right? Yes. Okay, great. So this basic degree of freedom relations understanding you should be having. Now next, Grashof's law. Every year you will see a question from Grashof's law. Okay, so it's a very basic thing. So you should know what the basic conditions, because in Grashof's law what it usually says, smallest plus longest should be less than equals to sum of another two link length. Now first of all, this Grashof's law is given for 4-bar mechanism. This is very basic thing, everyone should understand. It is given for 4-bar mechanism. Right. So this is our Grashof's law, right? Now please understand, if it is valid, then only we will say it is a Grashof chain. Then only it is called as Grashof chain. So smallest plus longest less than equals to P plus Q. Now one example I will show you. Cases. Case number 1, smallest plus longest is less than P plus Q. This is the case number 1. Under this we have 3 different cases. Now once you have understood this part, once this equation is satisfied, you will see which link is fixed. Okay, you have to identify which link is fixed and always see a link with respect to fixed, so smallest one. Always you have to see the link with respect to smallest one. How the fixed link has been placed with respect to smallest. So only the first condition we are having is smallest fixed. The first option that we have is smallest fixed. Okay, second option is adjacent to smallest. Okay, then opposite to smallest. Right. So these 3 things we should remember. So if smallest is fixed, I will say double crank mechanism. DC in short I am writing. Okay, it is called as double crank mechanism. And if adjacent to smallest is fixed, crank rocker mechanism. And if opposite to smallest, double rocker mechanism. Please remember these conditions. Very important, directly questions you will be getting from this conditions. First, Grashof's law, this case, smallest plus longest less than P plus Q. Then these cases, okay, 3 subparts of this case. Now, if we have, let's suppose second case, smallest plus longest equals to P plus Q. Now, in this case, what happens? Either it can be different numbers, 3 plus 4, that is 7, okay. Let me write it 3 plus 4, or we can write 2 plus 5, 7. And here we are writing 3 plus 4. Now 3 plus 4, 7, 2 plus 5, 7. Grashof's law is still valid. But S plus L equals to P plus Q and all the link length are different. If such type of case you are having, again this case, the previous first case will get repeated. Previous first case will get repeated. If you find S plus L equals to P plus Q, and one more thing, all the link length are different here. No doubt S plus L equals to P plus Q, but all link length are different, then this case will get repeated. But another possibility is there, or it will be having 2 plus 5 and 2 plus 5. This kind of pairs you will be having, or 3 plus 4, 3 plus 4. You will have an equal pair of link. You will have equal pair of link. That case is also possible. So once you have confirmed this is the case, when different link length repeated again, this first case will get repeated. But in this case what will happen? See, we will get 2 types of mechanism. First is parallelogram linkage. Okay, parallelogram linkage will be like this. Equal link length are placed opposite to each other. Then we have a deltoid linkage. this is smallest, smallest, and this is longest, longest. So in the parallelogram linkage, same link length are placed opposite to each other, but in deltoid it is placed adjacent to each other. It is placed adjacent to each other. So we have to understand this case is applicable whenever we have equal pair of link length, right? Now in this parallelogram linkage, no matter whatever the link is fixed, you will always get double crank mechanism. You will always get a double crank mechanism. This is the very basic point that everyone should remember here. Okay, I hope this point is clear to everyone. Yes or no? Correct. Now in deltoid linkage, if smallest is fixed, then double crank mechanism. So we should write always. And here is smallest fixed, then only you will be having double crank mechanism. Then only you will be having this double crank mechanism. So these are the cases that everyone should remember. Okay, so please make a note of all those things. Okay, quickly make a note of all those things. Done? Okay. So smallest fixed, and let's suppose if longest is fixed, you will be having crank rocker mechanism. But in parallelogram linkage, always a double crank mechanism you will be getting. Always double crank mechanism. Okay. But in case of deltoid linkage, smallest fixed, double crank, and if longest is fixed, crank rocker mechanism. Got it? Now, moving to the next part here. Mechanism. See, in our syllabus of simple mechanism, we will have three kind of mechanisms. 4-bar single slider crank mechanism, double slider crank mechanism. This is what our syllabus of theory of machine, if I talk about simple mechanism chapter. Right? Now, this transmission angle. Now, what is this transmission angle? We will quickly discuss this part also. Let's suppose you have provided rotation omega to this length, right? So you have given input here. You have given input. And you will be getting output here. Okay, so this link is actually the coupler we are having. So the coupler is a link which is connecting your input and output link, right? It is connecting the input and output link. The angle made by coupler with the output link is actually known as the transmission angle. This angle is known as the transmission angle. So based on different situations, they can ask the transmission angle. For that, what you need to know? Simply the sine rule, cosine rule. Okay. Triangle properties you need to know. In engineering mechanics last session only, I have discussed all the things. Sine rule, cosine rule, everything I have mentioned. So with the help of cosine rule, you can easily find out this theta as well. Okay. So this is what we need to understand for transmission angle. Now, moving to the next part. So that was the single slider crank mechanisms. Different types of single slider crank mechanism. If I fix cylinder, crank, whatever link I am fixing, accordingly I will get one of the mechanisms. So why it is important? Sometimes directly theoretical question they can ask, if in a single slider crank mechanism, if I fix cylinder, what kind of mechanism I will be getting? Example, IC engine reciprocating compressors. If I fix crank, what I will get? Whitworth or rotary engine, which is also having a name, Xenom engine. So we should know this mechanism names because it is important for our examination here. Okay. Similarly, connecting rod fixed, so crank slotted quick return motion mechanism. And if piston is fixed, hand pump or the bull engine we are having. Or in the case of connecting rod, another name is oscillating cylinder engine. So these examples we should remember, right? Now, there are two quick return motion mechanism problems, and I will tell you simple trick here. Okay, very simple trick that you need to understand. Whether it is the crank slotted bar mechanism or Whitworth quick return motion mechanism, you just need to know what is the extreme position diagram. If you know the extreme position diagram, you can easily solve any of the given problem, right? So crank slotted quick return motion mechanism looks like this. Okay, so this is what we have, basically a connecting rod which is fixed. This connecting rod is fixed. Okay, This is what we have, a slotted bar. This is what the slider we are having. Got it? So connecting rod we are having, and this is what the crank. So these are the four parts of our crank slotted quick return motion mechanism. Now you will see what kind of motion you will be having. This slotted bar will be oscillating like this. So one of the extreme position like this, another extreme position like this. So the slotted bar will be oscillating and the crank will have a complete rotation. Crank will have a complete rotation. So only the extreme position diagram is what required. So what I will do, this is the extreme position diagram. See how I will draw. Right. So this is the case. Now please understand everyone. So this circle I have drawn, if I draw like this is the crank which is having 90 degree with the slotted bar, because the slotted bar is tangent to the circle. Similarly, it will also be tangent here. Now usually in the question they will provide the dimension of connecting rod and the crank. So what happens here, okay, the basic point that everyone should understand, this angle, okay, is our alpha, which is cutting angle, and here the remaining angle is beta. So this is beta by 2. Now what I will do here, if I apply cos beta by 2, let's suppose I am giving the name here A, this is B, this is C. So in triangle ABC, okay, if I apply cos beta by 2, that is based upon hypotenuse. Base will be in front of angle perpendicular, base will be AC, divided by hypotenuse will be AB. Now you should understand AC is your crank, okay, AC is your crank, and this AB part is your connecting rod. Now please carefully understand this thing. So crank and connecting rod, it will be giving you directly in the question itself. Okay. So only this extreme position diagram is required for crank slotted quick return motion mechanism. AC, crank, and AB is a connecting rod. Both the values will be given to you. So from this relation, beta value you will be getting. Okay, some beta value you will get. Now alpha plus beta together it will be making 360 degree. Together it is making 360 degree. Correct? Together it will be making 360 degree. Okay. Now what is quick return ratio? It is simply the ratio of alpha by beta. Alpha is our cutting stroke angle divided by return stroke angle. That is what beta. So actually in another form I can represent alpha is the time required for cutting, beta is time required for return. Okay. So quick return ratio is basically time required for cutting divided by time required for return. That is actually corresponding to, if I say it is equivalent to, that ratio equivalent to angle during cutting divided by angle during return. Because as the crank is having constant velocity, constant angular velocity, right? So theta proportional to time. Now coming to the next part, we are having this thing, Whitworth quick return motion mechanism. Only one question till now they have asked from this Whitworth. Okay, I think in 2021 they have asked only one question. Again, very simple, only the extreme position diagram is what required. Okay, so but in this case what is the difference? It is having a rotation to rotation mechanism. Previously one link was oscillating, another was rotating. Here see, in this case what happens here, this is our crank which is fixed. This is our connecting rod which is known as driving crank. Okay, connecting rod. This is a driving crank. Again, this is our slider which is sliding on the slotted bar. This is slotted bar. Now, slotted bar is also under rotation and this driving crank is also under rotation. So, rotation, you will see here. Now, see, extreme position diagram. This is one of the extreme position diagram. This is another extreme position diagram, right? So this is before the cutting start, and this is the end of cutting. This is the end of cutting. Now, see what kind of extreme position diagram we need to draw. Simply, you need to draw a triangle here. Very simple case. Okay, let me just draw the triangle for you. Okay, now so this is what we have a triangle here. Now please carefully understand. Okay, let me draw it. Okay, let me just again draw it. See, first I will explain here itself. This thing I should write here, start of cutting, because if it is clear, then automatically it will clear to you. Start of cutting. Okay, this is the end of cutting. Right, so this is the start of cutting, that is what end of cutting. So see, in the start of cutting, the triangle is forming like this, and like this it is forming, correct? So what I have done, simply just I have taken the opposite of that. So I will just correct this part. Okay, now see, just a minute, yes. Like this, and one more line here like this. Now, so this is what the crank which is fixed. And here it is connecting rod which is acting as a driving crank. Okay, now please understand everyone. So here what are the angles? So usually students are confused about the angles here. Now this is alpha, cutting stroke angle, this is our return stroke angle, beta by 2. Now in this case also what I will apply, see, in front of beta by 2 this is the perpendicular, this is base, and this is hypotenuse, cos beta by 2. Again same thing I will apply. Cos beta by 2 is what? Base. Base is what? Crank, divided by hypotenuse. Hypotenuse belongs to connecting rod. It is a connecting rod, but in this case it is behaving as a crank, or I can say acting as a crank. Okay, acting as a driving crank we should say, because crank is already there but it is fixed. Right, so again same function, cos beta by 2. Then obviously alpha plus beta equals to 360 degree. That is what we know. And then finally, if someone asks QRR, quick return ratio, alpha by beta, cutting stroke angle divided by return stroke angle, or the time during cutting divided by return time. Simple thing, right? So that is also clear, everyone. So how we have drawn the extreme position diagram? Okay, this is what the start of cutting, end of cutting. Together I have merged basically. So this is the diagram, start of cutting, end of cutting, it is like this. So basically I have merged both the diagrams, right? So that's how we got the thing here. Now coming to the next part, 4-bar mechanism. Okay, very basic point you should understand about the velocity analysis. So quickly we will discuss about velocity analysis here. Now let's suppose first of all this link is fixed. Okay, how to draw the velocity diagram here? One basic example I will tell you, the approach basically. Okay, this is the omega angular velocity they have given, for example. This is omega angular velocity they have given, this is fixed one. Okay, now let's suppose the naming I will give here, omega A, B, B, C and D, right, like this. Now if it is given angular velocity in the clockwise sense, so the velocity vector of B with respect to A, it will be perpendicular to link AB, right? Now either BC link will be rotating clock or anti-clock, at this moment I don't know. So what I will do, I will draw the velocity vector. Okay, I will basically draw the velocity vector. Okay, let me just draw like this, perpendicular to here. Either the velocity of point C with respect to B can be in the upward direction or it can be in the downward direction. At this moment I don't know. Similarly of velocity of C with respect to D, perpendicular to link, okay, perpendicular to link CD. So this is velocity of C with respect to D, and this is what velocity of C with respect to D. So why I am drawing on both the side? Because actually at this point of time I don't know about the direction. That's why on both sides I will mention. Now once I will start drawing velocity diagram, it is clear about the BC and CD as well. What is the sense of rotation? Clear? Okay. So what are the fixed points here? A comma D. A comma D are the fixed points. So this point I will mention first of all. See, for B with respect to A velocity, it is written as AB multiplied by omega AB. So omega AB and AB distance will be given to us, and we can easily get the answer of velocity of B with respect to A. Right. Now fixed points you have already shown, A comma D. Velocity of B with respect to A will be like this. Right. Now this is you have drawn, so this is point B. Why I am mentioning this as a point B? Because I know the magnitude of this one. Direction also clear, magnitude also clear. So that's why I have mentioned point B. Next is what? Velocity of C with respect to B. So velocity of C with respect to B. So reference is B. So B point is already given. This vector as it is I will draw. Okay. This vector as it is I will draw like this. So this vector I have drawn, C with respect to B. Now velocity of C with respect to D, D is a point given, yes, it is a reference for C with respect to D. This vector I will draw from point D like this. So both the points are meeting here, that point belongs to C. So this is the velocity of B with respect to A, okay, and this is the velocity of C with respect to D, and this is what we will have a velocity of C with respect to B like this. This is what known as velocity diagram. Okay. So see, if you have understood the approach, you can solve any kind of problem with this approach, right? With this approach, you can easily draw velocity diagrams and you will get the answer of given unknown. Whatever questions they have asked regarding that unknown part, you can easily get the answer of velocity diagram. Now, this is the one way of solving the question of velocity analysis. Another way that we are having here is I-center method. For that, we have a one very important theorem, that is angular velocity ratio theorem, that I will discuss here, because most of the question that you can easily solve, okay, I-center method only, but here itself I will write angular velocity ratio theorem. With angular velocity ratio theorem, you will get the answer very quickly, and I will tell you the approach how to write the ratio of angular velocities, right? So let me just draw one FOBA mechanism. So this is A, B, C. Okay, better I will mention the link as 1, 2, 3. Then it will be clear. 1, 2, 3, and this is link number 4, right? Correct. Now please understand everyone, these are the link 1, 2, 3, 4. I want to write the angular velocity ratio. Let's suppose I want to write omega 2 by omega 1. Let's suppose omega 2 by omega 3. Okay. Now before writing angular velocity ratio theorem, we should know how to identify or locate the I-centers. For that, Kennedy's theorems will help us. Location of I-center first we need to know, then only I can apply this angular velocity ratio theorem, right? So omega 2 by omega 3 I want to write. So what I will do, okay, first I will mention the I-centers here itself, okay. For your clarity, I will simply mention I-centers here. So this is I-center I12, I14, this is I34, this is I23. Now remaining 2, 4 and 1, 3, where it will be there, okay. Again for that there is a small trick. Simply draw the 4 links here like this, 1, 2, 3 and 4, right. Now I want to find out link I-center 2 to 4. So in order to go from 2 to 4, we have See, what is the approach that we are using? Please understand. 2 to 4. So either I can go from I1 to I14. I1 to I14, right? Another way is I23 and I34. So from 2 to 4 there are two ways, 1 to 1 4, then 2 3 3 4. So 1 to 1 4 I will draw one line, 2 3 3 4 I will draw one line. Okay, 1 to 1 4 are like this. One line I have drawn. Okay, better I will use different color here. Okay, another line 2 3 3 4. Okay, like this. So both the lines are intersecting here. So this is the point I24. Similar kind of approach I will use for I13. For I13, see, for I13 what I will write from 1 to 3, either 1 2 and 2 3, 1 2 2 3, or 1 4 3 4, 1 4 3 4. So 1 2 2 3, 1 2 2 3 and 1 4 3 4. So wherever these two lines are intersecting, I will get the I center. So this is the point of I13, right? All the I centers we have basically located here, correct? All the I centers I have located. Now how to write angular velocity ratio theorem? Please everyone understand. 2 by 3 I want to write. So what is the common I center between 2 and 3? It is I23. First of all, omega 2 by omega 3 I am writing. So the common I center is I23. In the numerator, the distance of common I center from that I center which is there in the fixed, which is there in the denominator actually with respect to fixed one. In the denominator 3 is there, with respect to fixed it is I13. And again, distance of common I center from that I center, basically I center of the link in the numerator, that is 2, with respect to fixed, that is I12. I hope this basic things you are able to understand. Okay, so this is the one way of writing. Okay, one ratio. Let's suppose omega 2 by omega 4. Common I center 2 4. Distance of common I center from that I center of a link which is in the denominator, that is 4, with respect to fixed I14. Common I center. Distance of common I center from that particular link, I center of that particular link which is in the numerator, that is 2, with respect to fixed I12. Let's suppose if I have to write omega 2 by omega 3, common I center 2 and 3 already I have written, then I will write 3 and 4. Common I center is 3 4. Okay, common I center is 3 4, and distance of common I center from that I center of a link which is in the denominator with respect to fixed, that is I14. Common I center I34. Again, distance of common I center from that I center of a link which is in the numerator 3 but with respect to fixed, so I13. So that is the way of writing angular velocity ratio theorem. And I am telling you, if you see the previous year questions, 4 by mechanism questions they have asked, the only first thing that we need to do is I center location. Then out of 3 ratios, out of these relations, you will get the answer very easily. Once you have located I center, then using this relation, you will get the answer very quickly. Okay, no need to draw any velocity diagrams. With this approach, you will get the answer very easily. Got it? Now, next thing that we are going to discuss here is single slider crank mechanism. Now, in this case, 2 formulas that we need to remember is velocity of the piston or slider, we can say, and then acceleration of piston or slider. These 2 relations we should remember, because some of the times they have asked already this kind of questions. So here the formula is r omega sine theta plus sine 2 theta divided by 2n. These are the approximate relations we are having. Here it is r omega square cos theta plus cos 2 theta divided by n. Now please understand what is n. N is the ratio of length of connecting rod divided by crank radius. So these two formulas at least we should remember. Okay, so please note it down everyone fast, this part. Okay, everyone should note it down this part, because these formulas are very important, so you should not miss all these formulas, right? Done? Okay. Now, let me just write it. The next topic that we have to discuss is basically the flywheel. Okay. Now, in the flywheel, first of all, 4-stroke engine I will talk about here. Now, in 4-stroke engine, everyone knows the first stroke that we are having here is suction. Then we will be having compression here. Okay. Then we have a power stroke. Then exhaust stroke. So suction, compression, power and exhaust stroke we are having, right? Now, so this kind of variation we will be having if I don't use flywheel. So basically the purpose of flywheel is to what? To make sure that this non-uniformity should go away. So to avoid this non-uniformity in power, we will use flywheel and it will try to make it uniform. That is what the purpose of flywheel. Okay. So let's suppose with the flywheel use, this is the mean torque we are getting. Okay. Basically what is mean torque? Mean torque is that torque which is what required to run the engine. If at any point of time your actual torque is more than mean torque, engine will be accelerating. If your actual torque is less than mean torque, engine will be deaccelerating. If actual torque equals to mean torque, it will be running at a constant speed. That's what the basic understanding we should be having. So that is for the 4-stroke, but it is not necessary that always for a 4-stroke they will give. They can give any random cycle also. So some basic fundamental formulas we should remember. Like if I have to write work done per cycle, so it will be integration from 0 to time period. Time period is that point after which the cycle gets repeated. Okay. Same work done per cycle can also be written as mean torque multiplied by time period. Mean torque multiplied by time period. Got it? So integration of t d theta, but from 0 to time period. Time period is that point, okay, that point of time after which cycle get repeated. Correct? So like in this 4-stroke, after this again cycle will get repeated. Okay. Is it clear? So this point in the 4-stroke we will be having what? 2 pi here. Okay. So after 2 pi only, okay, our cycle will get repeated. Yes or no? Right. So here, if I have to write it here, so okay, from the starting itself I should write for you. Okay. So see, because it is not necessary that 4-stroke they will give, they can give anything. So the point is time period we should know. Okay. For example, sin theta is there. If sin theta is present in the function, time period will be 2 pi. Yes or no? 2 pi it will be there. For cos theta also it is 2 pi. Okay. So if sin theta cos theta is there, directly you can mention the time period will be 2 pi. So this much basics at least we should know from the trigonometry, right? So these two formulas are very important. Please note it down, these two formulas, everyone fast. Okay. And if most of the question, if mean torque they are asking, first you will calculate work done from this, then equate with this, and then you will get the mean torque. And sometimes this torque expression is not given, so what you will do, work done per cycle, okay, you will write area under T theta diagram. Okay, area under T theta diagram we are having, work done per cycle. Correct everyone? So just note it down this part. Okay. Sometimes students are confused, sir, if it is written sin 3 pi, sin 3 theta in the torque expression, or sin 5 theta it is written, then how I would write this time period? So let me give you this explanation also. If it is given sin 3 theta, so what you will write? 2 pi by 3, the time period value. If it is written sin 5 theta, so you will write 2 pi by 5, like this. Okay. Otherwise, in case of 4-stroke, see, whenever one stroke gets completed, okay, please understand, whenever one stroke gets completed, means from TDC to BDC or from BDC to TDC, what happens? 180 degree happens. Okay, got it? 180 degree. Here it will be 2 pi, here it will be 3 pi, and finally here it will be 4 pi. Okay. So in 4-stroke we have 2 revolutions, na? Okay. So for 1 revolution it is actually 2 pi for 2-stroke case. But for 4-stroke case, we will be having 2 revolutions, 2 rotations we are having. When this all 4-stroke is completed, suction, compression, power and exhaust, your engine has rotated by 2 revolutions. So that's why we will have 4 pi here. Got it? Right. So this much is clear. Okay, this is also clear, like how to write the time period. Now coefficient of fluctuation of speed and coefficient of fluctuation of energy and finally fluctuation of energy, these formulas are very important. So it is known as CS here. So how you will write? The CS value is basically max minus minimum divided by N average. Instead of N we can have omega as well. Omega max minus omega minimum divided by omega average. Coefficient of fluctuation of energy, same thing we will be having. Max minus minimum divided by average. Right. Fluctuation of energy, this fluctuation of energy formula, direct relation we have is delta E I omega square CS. I is what? The mass moment of inertia. Please understand, this omega is our average or mean omega. Sometimes CS value is given in percentage. Okay. If CS value is given as 1%, so okay, it is understood. But whenever CS value is given as plus minus 1%, so actually it means 2% they are talking about. Minus 1 to plus 1, that is 2 only. Please understand, 1%, okay, it is fine, everyone understand this thing. But what about plus minus 1? From minus 1 to plus 1, it is there. I hope this basic point is clear to everyone. So that's what we need to know in our flywheel chapter, right? Now gear train. Directly I will start the gear train topic, because from the gears usually they will not ask any kind of questions. Directly questions will be coming from the gear train itself, right? First of all, simple gear train. Okay, in simple gear train what we have, every shaft will contain only one gear. Every shaft will contain only one gear. So that we are having here is, this is one of the gear, this is another gear, this is another gear. If it is rotating clockwise, it will rotate anti-clockwise, and this one will rotate clockwise. So that basic understanding that everyone has. Now only one thing you should know about the idler gear. Idler gear is that gear which is the intermediate gear in simple gear train. Basically this red one is the intermediate gear. It is behaving as a idler gear. Idler gear, why we call it idler gear? Because it is not affecting the velocity ratio. Please understand this basic point. So the purpose is to what? Please understand, to connect the gears where large distance is required, to control the directional relationship. Clear? Is this two basic functions of the idle gear? Now one more thing, as it is having no influence on the velocity ratio, that's why it is called idler gear. If number of idler gears are even, direction will be opposite, and if it is number of idler gears are odd, direction will remain same. Like in this case, number of idler gear 1 basically. So clock here, you will get clock here. Again, in this case, instead of having one idler gear, we have two idler gear. Direction is going to what? Opposite. So in case of even, what we are having? Opposite directions. So this concept basically we should remember. Now, compound gear train. In compound gear train, any of one shaft can have more than one gear. Simply understand this point. Any one shaft can have more than one gear. That is what the compound gear we can have. Now let us look at this particular diagram here. So this shaft, if I talk about this shaft here, right, it contains this gear also. Let's suppose this is gear 1, gear 2, gear 3 and gear 4. So gear 2, okay, and gear basically 3 are on same shaft. Okay, which means N2 value equals to N3 value. So this basic understanding, again from the diagram also it is clear, and from this, either this diagram they will give or this list. Okay, this diagram or this diagram. Either of the diagram they will give. Okay, so from that we can understand what is the compound gear. Riveted gear train. Again, there is a small difference in riveted and compound gear train. Gear 1, gear 2, gear 3, gear 4. 2 and 3 are on the same shaft, so compound gear train. By default it is. But one thing you will notice here. Gear 1, that is input, where I am giving the input, and gear 4, that is output. Right? Gear 1 input and gear 4 output have, okay, we can write axis are, gear 1 and gear 4 axis are coinciding. So these 2 points we should understand. So gear 1 and gear 4 axis are coinciding. This is the basic point we should understand. Okay, that is what the differentiating point compared to compound gear train. There is no such condition in compound gear train, but in riveted gear train the condition is input and output gear axis should be coinciding. It is not the same axis. Okay, understand? It is not same, but the axis is coinciding. The gear 1, gear 4 are two different gears. They don't have any direct contact, but the axis is what coinciding. That is what the riveted gear train. Finally, the last topic that we are going to discuss here is epicyclic gear train. Okay, now what is the difference in other gear train and this epicyclic gear train? Very one basic difference. You will see this kind of thing. What is this? This is known as arm. So green gear can rotate about like this, blue gear can rotate about its own axis. Apart from that, okay, just I will take pen. Apart from that, this blue gear can rotate like this. Yes or no? This blue gear can rotate like this. Apart from rotating in its own axis, it can rotate like this. So there are more than 2 rotations are possible here. More than 2 rotations are possible. So that is what the main differentiating factor in epicyclic gear train. Okay, I hope you've understood this point. So this is only possible because of arm. So blue gear can rotate about its own center. Apart from that, it can rotate about the green gear also. Okay, now see this line diagrams. I'm telling you guys, only one question they have asked till now in the previous year questions in the gate. Only one question they have asked where they have given the line diagram. So many people find line diagram questions are difficult. No, if you just understand the basics, how to draw the line diagram, you can easily solve that question also. I will show you which question I am asking here. Okay, which question basically I am talking about. So this is the external meshing. Either it can be represented like this or like this. So this is our line diagram. Okay, this is what we have as a line diagram. Okay, this is what the line diagram we have. This is for internal gear. Okay, the line diagram. Now see how the teeth are cut for internal gear and how the teeth are cut for external gear. This is external gear, right? And this is what the internal gear. So how the teeth are cut here? I hope it is clear. Now meshing of external and internal gear. How the meshing has been represented? Whenever meshing happens, these 2 parallel lines they will show. So when the teeth has been cut inside, so this is representing what? Internal gear. If the gear they have mentioned like this, this is external gear. Whenever teeth has been cut inside like this, so this is what? Internal gear, this is external gear. Right? So these 2 parallel lines is actually representing the meshing between the gears. Now, this was the question. Please understand, this was the question asked in GATE. Okay, GATE 2010 they have asked. And many people find this question as tough. And I'm telling you, if you have understood the line diagram, then this question is again very easy. And I hope everyone remembers in the classes we have discussed about relative velocity method. We are not going to use any tabular or conventional method here. We will always use the relative velocity method, because with that method you can get the answer in within seconds. Within seconds you will get the answer. So with such method only we will be using in competitive examinations. Tabular or conventional method is usually used in university examinations, not for competitive examination. Now, I know many people find the difficulty. Anyone who has solved this question previously, so they can mention their answers as well. Okay. Relative velocity approach. I will tell you the concept how to solve this question. Basic concept. Relative velocity method I will tell you, and how we can solve this question very easily. Okay, see. So this is the diagram. First of all, you need to understand the gearing, okay, how the gears are meshing. Gear 3 and gear 2 are meshing, okay. 4 and 5 are meshing, okay, fine, no issue. If you see the gear 5 teeth has been cut inside, so that is the internal gear. 5th is our internal gear, that is the one thing you should understand. So 5 is meshing with 4, okay. 4 is our external gear, because the line diagram is for external gear only. But one thing you will understand regarding gear 3 and gear 4. What happens, or what is the relation between gear 3 and 4? Is there any relation between 3 and 4 gear? Obviously, both are on the same shaft. If both are on the same shaft, what will happen? N3 equals to N4. Both are on the same shaft, so they will have same speed of rotation, fine. Then 3 is meshing with gear number 2. According to relative velocity method, if I am writing, let's suppose 2 meshing with 3, so 2 with respect to arm I will write first, divided by 3 with respect to arm. So it will be minus T3 by T2, that is the first relation, because 2 and 3 are meshing. Now another relation between 4 and 5, because 4 and 5 are meshing with respect to each other. 4 with respect to arm, speed of 5 with respect to arm. Now whenever internal meshing is there, so speed of rotation have a same sense of rotation. Rotation will be having, both the gears will be rotating in same direction. Both the gears will be rotating in same direction. So here T5 by T4 will come, but with the positive sign. Here the negative sign come because of external meshing. Whenever external meshing is there between gears, sense of rotation is opposite. For internal gears, the sense of rotation is same. It is not going to change. Got it? So this is equation number 2. Now actually if you see the question, what they are actually asking here, they are asking the angular velocity of 5. Okay, and they have given angular velocity of arm. Okay, angular velocity of arm they have given, and for 2 it is given. Okay, 2 it is given. So if I multiply both the equations, okay, so what I will be getting, if I multiply both this thing, 2 with respect to arm divided by 5 with respect to arm, minus T3 by T2 multiplied by T5 by T4. So 2 they have given, arm they have given, 5 they are asking, and all the values are given. Now they are asking in what? Radian per second. So I can mention instead of n as omega as well. So there is no problem in that. Instead of writing n, I can mention omega as well. Okay, there is no issue about that, because the ratio of n or omega are same. Are you getting my point? Same thing, I can write it like this. Omega 2 with respect to arm divided by omega 5 with respect to arm, which will be minus T3 by T2 multiplied by T5 by T4, like this. And from this you can easily get the answer of omega 5. And I am expecting everyone, so that you can solve this question, and please, I am expecting from you guys, mention the answer in the comment box also. If you have solved this question, mention your answer in the comment box, okay? And I will see how many students has solved this question, right? So I hope the approach is clear to everyone. Now in this session we will discussing till this gate train part only, that is our last part, epicyclic gate train for this session. Remaining topics like vibration, balancing, okay, gyroscope, these kind of topics we are going to discuss in the next session. So till then, please keep revising, keep learning, and keep your full efforts for your gate 24 examinations, right? So we will meet in the next session, and we will cover all the remaining topics of theory of machine, okay? And please join the Telegram group, guys. Again I am telling you, because all the PDFs you will be getting there itself, okay? all the PDFs you will be getting there. The Telegram link is this one. You can join this link and you will get all the PDF of the lectures. Apart from that, latest job notifications you will be getting, daily quizzes, YouTube lectures, every details you will get in this this Telegram channel. Apart from that, IMS Gate Academy live program, which is having more than 800 hours. The main important thing is this 12 mentorship sessions, one-to-one analysis you will be having, one-to-one discussions you will be having with the faculty. Okay, you and the faculty will be there. Personal attention to each and every student will be given here. So that is the main advantage of IMS Gate Academy programs. Apart from theory books and exercise book, so that you should not be dependent on another source of materials. And if you want to have a conversation with our counseling advisors, you can book a counseling session, free counseling session. Just book, call this numbers. Call on this number, book your counseling sessions, and have an idea how this IMS program, live program runs, right? So thank you so much, guys. We'll meet in the next session with remaining topics like vibration. That is most important part of the entire theory of machine, and also we'll be discussing gyroscope and balancing part. Okay. Thank you so much, guys. We'll meet on the next session of theory of machine.